Alright, top is welded. Started going down the side. I took off this bracket which holds the whole assembly together, and I'm going to get that part, glue that in, and then get to it. Get to the bottom where it's broken. Bottom where it's broken. Get to the bottom where it's broken. And then you clean up the inside doing there. But the thing you got to worry about when you're using a little dink 110 wire welder to do real steel is you can heat it up and you can get penetration, but because it's flux core, you got to worry about voids in your welds. And the voids are when you have the flux core wire has flux inside of the wire, and you end up, if you're not careful, ending up with pockets of the flux inside the weld, which is basically a hole in your weld. It's, it makes it very weak. You take your time and you keep the heat up, the flux floats to the top, and I guess I should have left some on and then rubbed it off so you could see it, but I didn't. But on the next one I will chip the slag off, which is the flux. If you have a regular stick welder, the flux is the powdery crud on the outside of it. It's kind of like a hard powder. If you're MIG welding, you're using an inert gas. It's metal inert gas. It's MIG welding. You don't really need flux. You clean everything really good, and then you don't have any oxidation. When you weld, you're actually, a percentage of the carbon in the steel gets burned out of it, and the flux floats it to the top, and that's the significance of it. But when you're MIG welding with metal inert gas with a stick, or TIG welding, you don't use it because without the oxygen you don't have the burning of the carbon, so you don't have the slag coming up. A little bit of a tangent, but anyway, I'm going to keep going and hopefully not have to smash this thing with backhoe.